Okay, fine. Convergence of IT and OT technologies. IT is nothing but an internet of information technology, and OT is an operational technology. So they begins with the adaptation of network protocols, technology, transport, and the methods of IT organization. So here that IT organization is beginning to support the operational requirements of the by using that operational technology. When IT and OT begins with the same networks, protocols and process, there is a clear economics for scale. So here the data is going to be basically scaled. It means to say that the OT is looking for towards IT technologies with the open standards such as Ethernet and IP. In IT, it becoming more towards the business partners. OT by better understanding business outcomes and operation requirements. Now, I think you understood what is that IT. OT is majorly considering towards the technologies with open standards. But in case of IT, it is towards the business partner, but operational by better understanding of business outcomes that it is going to be get considered. The major challenges in this are IoT have become a reality, but certain obstacles are there in this. They are scaling, security, privacy, big data analytics, and interoperability. Scaling is a large scale. The data is getting connected and collected. Security is a major threat for this because as it's the open standards are there, anybody can interact with the things. Social media, good things are, bad things are there. So many n number of people are getting connected, disconnected, and all the precious data that are going to be taken and morphing everything that they can able to do it. So with the distant location, Wi-Fi, okay. WiMAX, so many things are technologies are going to be there. So these things they will going to use, and they can hack the system and they can do many things. So security is a major thing that we have to consider for this. Then privacy, that's what comes under mind. Then big data analytics, collected more data is there, where you will be going to keep it. So ultimate solution is the cloud. So again the charges are going to be more for that. Interoperability, the data is getting collected, then it should be screened properly. It means that only the things which is required that it should be taken, and based on that decision is going to be made. Again another set of data is going to be taken. So like this the data are going to be get interacted, and the actions are going to be taken on that. So this itself is a big task for the IoT, because decision has to be taken within a fraction of seconds. Very difficult to make this one. IoT has architecture and design. So here what happens, the architecture is going to be designed for this. It means to say that how it is going to be designed basically. So it needs the architect. So many challenges will be there. First challenge is information technology. It needs to be designed with withstand the network earthquakes, such as distributed denial of services, that is DDoS attacks, future growths of requirements, network outrages, and even human errors. That should be the big challenges for to get started with this network architecture. Some similarities between IT and IoT architectures exist. For this, the challenges are requirements of IoT systems are radically different from those of the traditional IT networks. Okay. Then the challenges for this is posed on the IoT networks, and how these challenges have been driven new architectural models and all these things that we can discuss. It explores here the design of the network, drivers behind the network as architecture. What are those? OT, that is operational technology. Networks drive core industrial business operations. They have unique characteristics and constraints that are not easily supported by the traditional IT network architectures. That is the network architecture concept of it. Then comparing the IoT architecture, different. Several architectures have been published by IoT, including those ATSI and IoT World Forum. There are differences will be there, so those things are going to get resolved by using their organizations. Third one is a simplified IoT architecture where the data is going to be, the more data is going to be is compressed over here. So here, while several IoT architectures exist, a simplified model is going to be taken from that. Then the core IoT function stack. This is one layer network, as I said. The IoT network must be designed to support its unique requirements and constraints. Finally, the IoT data management and computer stack. These are the things that we will be going to discuss in detail in the next hour. Introduces the data management, then including storage and compute resources models for an IoT, and involves edge, fog, and cloud computing. Same thing that it is here. Some differences are going to be there. Those differences will be contained in the architectures and all. IT and IoT networks, scaling, security, devices and network constrained by power with the CPU, memory, and link speeds. So as you see that in the scaling, IPv4 is going to be there. It is going to have addresses, limited addresses, so that it should be changed to the IPv6, so that more number of data can be accessed and transferred. In the security, it is especially those works with the wireless sensor networks, so physically exposed to the world. So very much care has to be taken on that. Security is required at every level of the IoT network. The IoT's endpoint locations is very important thing to get the data and receive the data. The authentication and authentication protocols are going to be used for encryptions and decryptions. So it must also be easy to deploy with some type of zero touch deployment model. That's what I said. So whenever that you want to use this model IoT, so cashless transactions are going to be more secure. Then device networks, as we said, input CPU, memory, and link speeds and all. Without the data packs, so it is very difficult to manage this. So the last mile wireless technologies are more needed to support the constrained IoT devices over the long distances. Anything that you wanted to reach that, so we need last mile wireless communication system that is required. The network is also constrained, meaning modifications need to be made to traditional network layer. That has to be changed. The massive volume of the data generated from that.